Hello, my name is Wolfram Müller. I'm the founder of Blue Dolphin, the first international community of people and companies who want to reach hyperproductivity based on self-organized change and theory of constraints. Yes, and you can imagine that's not always easy. And to reach hyperproductivity, you have to first reach flow. So the work is flowing, and due to this, the companies are mainly overloaded or at least loaded. They have to reduce the work in progress first. And we are not talking about a few percentages, but we are talking about a reduction by 50, 60, 70% or something like that. And therefore, they have to decide which projects stay active and which have to be postponed. For manager, this is a big challenge, and they need data and transparency about that. And we understand that, and therefore we developed a tool. It's called SmartPipeliner, and it's all about finding the right work in progress and finding the right decisions in an easy way. So let's start. I just want to show you in this tutorial how it works, and then you can do it on your own. So I share the screen with an Excel file with the SmartPipeliner. And here you already see the SmartPipeliner, the intro, and you can see a link on the tutorials and of course the history. In the end, it's all about this. We want to have an overview about the teams. So we have here, in this example, 3 teams: development, product management, and quality assurance. We want to see the projects. We want to see a timeline when the load occurs of the project, what the capacity is in the rollout situation. So that's the final result. And to get this, we have to put in some data. And everything starts with the teams. As I already said, in this example, we have 3 teams: development, product management, and QA. And you just list the teams and the team names and the responsible persons, of course. So that's the first step. And you already realized we are talking about capacities and load and stuff like this. So we are working here with person days normally, but you can choose, of course, other stuff. But in the end, we are talking about persons and load and person days. So in this sheet, you just name the teams, and then it starts already getting a little more tricky, and I just show the standard right now. Behind this, you have a calculation of the capacity. And the capacity is more or less dependent on how many people are working in a team and the project quota, how much of their time they really can invest in project or initiatives. And we are not distinguishing a lot between agile and classic project management. You can talk about projects, you can talk about initiatives, you can talk about releases. In the end, they are important deliveries, and they need some load, they need some effort to do, and some in the teams you have some capacity. So you can do both classic and agile within the same Excel sheet, no problem. And each team is defined by more or less 2 parameters: the number of people, the full-time equivalents, of course, and the quota of how much they can invest into these initiatives. In this example, we have 1 quality assurance guy, we have 1 product manager, and we have 3.5 developer. Maybe these are 5 in reality, but there are some part-time people, so in the end there are 3.5 FTEs, and from this FTEs 25% go into daily work, so there's just 75% for initiatives left. The product manager has no daily work, he has just to do projects, and quality assurance has to do some stuff too. And you already see it can change every month. You can change the data. Sometimes persons come on top, so you can easily change the 1 to a 2, and then after that there are 2 product managers and so on. So this is more or less your current staffing, and maybe some ramp up. And out of this data, that's a little more complicated, and I don't show it in this sheet how it goes, in this tutorial how it goes directly. I will show it in the next one. Out of this data, project quota, and the number of people, and some model how many days you have per month, you calculate how much person days per team are available in each month. So here you have the month, here you have the person days, the capacity, and you see even in these teams it varies a little. It's dependent on the vacation stuff and stuff like this. So, and in the development you have more people, so you have more capacity, and in the QA you have again just one person and a little less. So that is the basic. So you have the teams. Each team has a responsible. The team has a project quota and a capacity, of course, in FTEs. And out of this, the capacity is calculated. So that's a baseline capacity. The next step is, of course, to define the projects. And that's not very complicated. So you have here a list of 6 projects. I just generated 6. Every project has a start date, a year and a month, and that comes afterwards. If you prioritize, that's the activity level, it's a number that goes up, and you can decide here which of these projects are in and which projects are out. So that's a definition of the projects. Important in this is the sort order of this list decides in the order in that the load is aggregated. So it's not a priority A, B, C. It's just, okay, the first project loaded into the pipeline is 1, then 2, 3, 4, 5, 6. So the order in this list decides the order how the projects are loaded. And the only thing missing now is the definition of the projects. So behind every project here, there's a small sheet, and this sheet defines the load. So in this case, we have the 3 teams, and you already see the load is defined relatively. So in the end, you have to decide whether to do the project or postpone. So it's all relative to the start. That means in this project, that's a medium-sized project, in the first month, that's offset 0, of course. You need maybe 12 person days of the product manager. He has to think about the product. In the next month, he maybe has to answer some questions and so on. But after defining, or in the phase of defining, the development has to be part of it, of course. Then they start to develop, and the last month is more or less a cleanup. And in parallel, quality assurance starts. I'm a friend of starting quality assurance ASAP. So they have some work here, a little more there. In the end, they do the testing, of course, or at least guide the testing and some cleanup. And that's a definition of a project. This is greenfield, so you calculate the load in a way like it would be the only project in the company. So you have all available resources at hand, a very tight timeline, not a long timeline. So this is the fastest possible way to do this project if it were alone. So in 5 months, everything is done. So, and you see there are other projects with other footprints. So every project has some kind of a load footprint. And the Excel, the only thing what the Excel does, if you go back to the project list, you can press this button, generate team balancing plan. And if you press the button, it takes the project number 1, puts the load in the table here, and it takes project number 2, takes the load out of the sheet, the next one, and in the end, it adds up all the loads. That's it. On the other hand, you have the capacity of the team, so you can calculate easily the overload, and you see already this won't work because in October there's a 149% of load, overload of 50%, something around that. Here it's twice overloaded. So this schedule of projects, initiatives, releases will never work simply because of the development. Another interesting line here is the aggregated overload. So that's often missing into tools. So in the first month, you have an underload, so there's no overhang. So no work left over. In this month, it's 21 person days left over. So they come on top to this overload. And just in the month March, it's the first month where they have underload. They can work on this overspill, and over the time the overspill goes down. And in this schedule, in the July, it's the first month where the team has real capacity left over for new stuff. So it's not just an overload in the first month, but the overspill, to clean up the overload, it's additionally 4 months needed to get all the stuff done. So, and that's the base for any kind of decision making. There's of course another view. This view just shows the percentages of the load, and on the right side you see a graph where you can see, this project number 5 is in this month loaded into the system, but currently project number 2 is running, so you have a little graphical overview about from which projects the load is coming. So, and that's already part 1. That's everything you have to do to enter data, to get a team balancing overview, to get a possibility to make a decision. So now, if you have done this, the next question is how to come to a good pipeline, to a balanced pipeline, how you can find the constraint. And the thing goes typically in 1 or 2 steps. The first step is you go to the project list and you set all projects to the current start date. That seems a little awkward, but you look at the organization like every project starts immediately. That's the easiest way to identify the constraint, and you see everything starting immediately. And you see that the loads are high right from the beginning. What you also see is here the average load, and you can see already, development is not overloaded over the next 12 months. It's somehow okay, product management not, but the real problem is quality assurance. So what we typically do is we change the order of the teams that are displayed here in the order of their overload. So you take the QA on top, then you have the development and product management at last. So you can concentrate on the first team to bring that in a positive staggering. So you already identified the constraint. Typically quality assurance, or in this case quality insurance, is a constraint. If you click at team balancing sheet now, you see quality on top. So, and the next thing is, if this order here of projects shows the relevance, the business relevance, then it's clear that you have to freeze or postpone some of the projects. It's not possible to do everything. So if you want to reduce this overload here, then you have to move some projects. And you can do it in different ways. A very simple way is just to make a wild guess. And there's some small hidden feature in this. So the first project has to stay, of course. And you have here the load 8 and 5. That means that's 13. You have a capacity of 14 in this team. So maybe in this month, these are full. So you can already start to move all these 4 projects by at least 2 months. So you can just add, okay, postpone them by 2 months, and I can promise you, you have to postpone the others by more. So, and that's the first step of staggering. Staggering is a name for ensuring that the constraint, in this case the QA, is not overloaded. And there's a small macro included here. It's called let's move it. And it does nothing else than updating the project list. So in the project list, you see now that it added 2 months to the start month. This is a small bug. There's no 13th month, but it works anyway. Now you see that the load is already reduced. Of course, you can overload the team by starting the project 3 a little faster, but this is just 1 person day. I don't care. So this will work like this, but it's not enough because you already have here 5 days too much. So you can add already 1, and you already see, okay, the next month, the next project will not work there too. So you can postpone it even more to get a balanced load. Let's move it again. It's getting better. So we have 92, 99. That's fine. Okay, this project really hurts because it generates the next overload. So you already see that it's not so easy to get the load down in the constraint. So maybe again a few moves, and that's the way how you do it. So now you have here a 146, and that means even these 2 projects already generate an overload, but you can't avoid this. But what's important is that if you move the projects like this, in the next month they have 80% load, and the aggregated overload is already reducing by 3 days. So this 146 and the 80%, they are somehow leveling out. More critical is here this 170%. So again, you have to move these projects by at least 1. So and you see, okay, it's a little annoying because you don't like it like this. So here the aggregated load is again nearly gone. Here you have again an overload, but you can't reduce it easily. So you have to wait again here like this. And maybe this was one too much. So you can pull this 1 month earlier, and then it should look okay. So you have some peaks here, but they are reduced in the next month. So we have 131 here. So this may be an indicator to move this at least 1 month, and then you are really on a good balanced sheet. But now you can see something very, very interesting, and that's the base of theory of constraint. If you are dealing right with a constraint, so we did not overload the constraint anymore, so it's a little and slightly underload, that's fine. then you see that all the other teams are not overloaded anymore. So development has enough capacity to deal with problems, and product management was never a problem. And now you see also in the sheets, in the graphical version, you have some peaks, but you already see it's leveling out. Development has some spare capacity, and the product management no problem at all. So, and that we are calling a balanced load. And now you have a project list, and you see here, okay, these are the reasonable start dates. Now you can correct this bug. So it's not 15th of 2020. It's in 2023. But you know already the end date. So, and these end dates are the dates you can commit to your business. And this is one job you have to do. You can, of course, change the order here. You can redo the pipelining. You can think about moving resources back and forth. You can do everything, but the only thing you have really to do is that here in the end, there must be a 0, so the load has to be balanced in the end. Typically a load something around 90–95%, and the constraint is absolutely okay, because always is something's happening. So that is what we are calling team balancing, load balancing, find the constraint. And that's the most important thing for any kind of change, regardless whether you're agile or classical. Yeah, thank you for your attention. I hope I was able to show you a little how this SmartPipeliner is working. And as you know, the smartness is not in the tool. It's always before the screen. So enjoy it. And it's very helpful. This tool is used by many companies around the world. It's this daily business for them to keep the load under control. Thank you and have a nice day.